Hello, for this assignment I'm going to draw 4 amino acids from the hydrophobic group, polar group, acidic, basic, one from each, and then I'm going to draw them at pH 0. So to start off, I'm going to go to the draw one from the hydrophobic group. These are also non-polar. Alright, so I'm going to draw glycine at pH 0. So it has a carbon, alpha carbon, hydrogen here. It has a carboxyl group here. The proton is still here because it's has a pKa of about 2, and we're below that, so the proton stays. To the left, you have the alpha amine group, NH3+. Oh, that's wrong. So there's 3 hydrogens, NH3+. Cool. And this also still has this proton because I believe it's a pK of about 8. And then above, it's just going to have a hydrogen. Next, I'm going to draw a polar amino acid. So the one I chose is going to be serine. And that's going to be at pH of 0. So same basic structure, H. And carboxyl group still has this proton because, again, it's a pK of 2, and we're at pH 0, we're going to have amine group, NH3+, proton still here because pKa of 8. And then what's different is going to have a CH2 and then an OH group on top. Next, we're going to talk about, I'm going to do a basic group. So for the basic group, I chose lysine. Lysine at pH 0. They're all going to be at pH 0, but I just draw it. So the same basic structure, carbon, hydrogen, COOH, carboxyl group. Again, H is there because it's at pH 0. That's a pK of 2, so it won't fall off at pH 0. You got the amine group. And then you're going to have CH2 to the 4. So there's 4 of those groups attached to NH3+. This also has it actually has a higher pK of about 10.8. So that's what will be the last proton to fall off versus this one right here, which is connected to the alpha carbon. Lastly is going to be an acidic amino acid. Acidic. So what I chose is aspartate, I think that's how you say it, at pH 0. So this one, you're going to have a carbon, hydrogen, carbon, our carboxyl group still on because we're at pH of 0, which is lower than a pKa of 2 there. And H3+, pK is around 8, so this still has this proton here. And then what's different is up here we have a methyl group, and then we're going to have C double bonded to a O, bonded to a hydroxyl group. And I believe at pH of our neutral pH, this hydrogen comes off, and it's like a resonance structure here. But because we're at pH 0, this hydrogen's on. I'm not sure what the pKa of this hydroxyl group or the hydrogen here is. I'm pretty sure it's around 5 or 6. But because we're at pH 0, we're going to have that OH group here. And that's it. Thank you.